I did not realize today during class that the extra credit assignment would take as long as it did, but it was still a good assignment, and I hope you all enjoyed it and you learned something really good today. So what we're going to do is show you what I also wanted you to see today, and that is how to solve more of these types of problems. They all have something a little bit different. So I wanted to give you, out of tonight's homework, a couple of the problems for free. So just copy away to your heart's delight, and please make sure you understand what's going on. In this one, how many grams? For the first time, we're actually having to know what the gas is. And so it makes things a little bit different than you've had in the past. So as you look at the problem, hopefully you can see why grams of CO2 is the find. And there's our passing bell. But the volume is equal to 1 liter, and that's pretty easy to see. But because of STP, okay, the from STP, we know that 22.4 liters is equal to 1 mole, and because the STP is stated in the problem, we know that this is going to be true. So we can use it in our calculation. We don't have to use we don't have two sets of conditions, so the combined gas law is essentially useless. So here's how we want to start this thing out. Let's get this little guy out of the way now. And we start with our given over 1. That's no big surprise, is it? And then next, we're going to use the actual molar mass of the gas, which in this case is carbon dioxide. And for carbon dioxide, we have carbon and 2 oxygens. When we add the molar mass up, this is not going to, we're not using the molar mass now. Excuse me. We're using this guy right here. 22.4 liters equals a mole, because that's how we're getting to grams. We've got to get to moles before we get to grams. This is almost sounding a little bit like the stuff we did in prior chapters now, isn't it? So, as we move along here, whoa, I just lost something in there. There it is. Okay, that's what I was after. And the molar mass for carbon dioxide is actually 44 grams. So 1 mole on the top here, moles on the bottom here, and that gets us to grams. At STP, it's pretty sweet. And this is going to be, of course, our final answer. So the 1.96 grams of carbon dioxide. So as we're doing the problem, we of course want to cross out our units of measure. And of course we're ending up with 1.96 grams of carbon dioxide as our final answer. And let's get this guy up here as the box around our final answer. The next one is number 33, and let's get the shade up and take it a little piece at a time. Okay, this time we're dealing with something called ethylene, and they actually gave us the formula so we could figure out the molar mass, which is kind of nice. So we're starting with kilograms. That's going to be a problem. We've got to get that into grams because we can't get molar mass in kilos, because periodic chart doesn't do that. So what I'm showing here is, first of all, I know I'm going to need the molar mass, so I'm going to add that up over here. And here we're given the kilos of ethylene, and the volume of ethylene is what we're looking for. And because we're at STP, we can use this equality. So we're going to do it like before. We're going to start out with our given over 1, but we get the kilograms have to be changed into grams, and it's 1,000. Whoops. There, come on, stop doing that. There we go. 1,000 grams of ethylene is 1 kilogram of ethylene. And if you had to make that little conversion factor, just remember that kilo means 1,000. And if I put the 1,000 into the place where kilo is, that's what I've done up here. So 1,000 kilograms is 1 gram because kilo stands for 1,000. All right. And next up is this little guy here. 1 mole is 28 grams that we calculated over here. And the last little thing that we put in there is the number of liters because now we know the moles. So we're starting from kilos, going to grams with this fraction, going to moles with this fraction based on the molar mass, and then the STP is our friend for the end. And that gets us to the final answer of 3,600 liters of ethylene. This could also be written, by the way, or alternatively, we could convert that into scientific notation, and for that we'd have 3.6 times 10, whoops, should be cubed. And there we are with that corrected. I hope you found this helpful for your homework tonight. See you at class tomorrow. Bye-bye.